on the unit is what I will do today. Along with that, we'll cover the first learning outcome. And once this is done, you have a schedule. I have not posted the links to the session today, but what I normally do is before I start off the session, just a couple of minutes before the session start, I will also post the meeting code so that if you are not having it to hand or don't have it to hand on your phone or on your PC, then at least you are able to, obviously get on with by looking at joining this session. So let's start off with understanding this particular unit, which is what we are looking at is called the Introduction to Digital Technologies. So give me 1 second. I'm not sure where that is. There we go, on the screen. So these sessions with me normally tend to be about an hour long. If you do feel that I have that nag of speaking a lot. So if you do feel that it is quite detailed and you feel that, I need to, kind of tone it down, then do get me that feedback, because at the end of the day, I want these sessions to be as detailed as possible so that you are able to, obviously get a very good grasp of anything that we are discussing. Most of the sessions that I will carry out, this is not something which I am preaching, but I would say that about me. Most of the sessions that I do are tending to be very detailed. So 90% of the information will actually come from my sessions. And I would also, towards the end, give you some bit of reading to do, which is going to be directly related to the learning outcomes that we are studying and the assessment criteria, so that at a later stage, when you have to look at going into doing the assignment, you would not need to go to Google or search for books or information, elsewhere. Everything would be available from the Moodle itself on the course as far as we are concerned. Now, there are different units, as I mentioned very quickly. This unit is only 5 credits. So obviously what my suggestion would be, although it says 30 guided learning hours, this is a unit which covers topics that we are very familiar with. Things like, 3D printing today, you look at the advent of AI, you look at, for example, anything new which is happening in the field of technology. When we do talk about quantum computing, we talk about, say, the use of broadband. When we look at fiber optics and speeds which are 1 gigahertz. So these are things which are related to what is called digital technology in particular. So if you were to look at why do we want to study this unit in computing, and especially so at level 3, the reason is that when we do talk about computing, one of the things that we have to be talking about now, because we're not in the 90s era when PCs were big as your desk, or some of them in the 80s were big as your room. Today, they have all got squeezed down to a phone, and the phone that you carry in your palms essentially is I would say, a computer itself, because you're able to do everything. Take pictures, talk, send messaging, access emails. You're able to do even multitasking while, say, for example, sending an email, watching a video on YouTube and things like that. So they are basically, I would say, supercomputers in your hands to a certain extent. Now, the reason why we want to study this is we want to look at a broad angle of what are the range of digital technologies available today and how they can be put to use in the business context. So when we do say digital technologies, what I mean by that is, if I have to define that term, it means electronic systems or equipments that we can use, which have some sane sense of being IT related. That means they can create, they can process, and they can store information in them. So anything like I use a memory drive or a pen drive, if I might put it this way, if I use a pen which has a built-in memory in it, if I, for example, use a digital camera, which I'm using now for the Zoom session, I use a monitor, I use a keyboard. These are all part and parcel of what are called digital devices, because they help you connect to a particular system or an ecosystem. And when we do talk about them, there are 3 of them or 4 of them in particular. One of them is a PC or a personal computer. Then you have laptops. Then you have servers or cloud-based systems which essentially store data on the cloud. And then you have devices which can help you access this information. So these devices can be terminals, thin clients as we call them, tablets, PCs, your smartphones, because they all allow you to connect to information to be able to carry out various forms of activities. Now, on the phone, The processing is normally done through a digital spectrum. You have telecom, 5G, 4G, 6G now being tested. You are able to use voice telephony, and you're able to use messaging, which is through email oblique short text messages, or in the case of Apple devices, FaceTime or iMessage. In the case of Android devices, it is normally Google Meet that you can do. And these are all technologies which are allowing you to communicate, create, process information. And that is why the unit digital technologies, because what we want to be able to do is understand that digital technologies refers to electronic systems, tools, equipment, which allow you to create, store, process information, and in some cases, allow you to even transmit, information to other such devices. So if you come across a word called digital technologies essentially refers to what is called electronic systems. And that would be the definition of it. And if somebody is going to ask you, can you give me an example of few digital technologies? So we can classify them into various types of platforms or categories. One of them tends to be devices, tablets, PCs, phones, smart TVs also, because you are able to browse internet today on those TVs. They have the ability to be able to store information, which is like a EPG or an electronic programming guide. And you are able to see what is going to be broadcasted 1 month in advance on Sky or Hulu or Flick TV and things like that. Software applications, systems, and then you have online platforms or systems which can be used to store information on the cloud. That means they might not be physically in the same premises as you, but they will still be present wherein you have access to the devices through the internet or broadband. And that allows you to, again, control processes for the fundamental reason of sending, receiving, and, creating information. Now, when we do talk about digital technologies, there are different types. This is something that we need to understand just as an overview of this unit. Now, digital technologies or equipment, as we call it, electronic equipment, can be of different types. We are all aware of computer systems. We've used a PC or a Mac at any given point in time. We have seen some of these devices like thin clients, point of sale terminals. When you go and shop at Tesco's, when you go to Waitrose, when you go to Sainsbury, you go to ASDA, where on the tills, the operator is actually scanning those products to see what you're shopping in the basket, is basically an electronic point of sale machine, or POS as we call it. And those are all part and parcel of what are called operating systems, because computer systems, because they have some sort of an operating system installed on it. So this is one type of computer equipment or electronic equipment which is classified as a digital technology. The second tend to be networking technologies. We look at router, switches, you look at servers. Some part of it would be devices that allow to extend the bandwidth of the network. So for example, you have wireless extenders, you have intelligent switches, you have hubs, you have EPBXs, and sometimes you have what are called bridges. Now, I don't know how many of you have, say, for example, an Amazon smart speaker at home, or lighting, the Hue lighting, which is Philips Hue lighting, or any such form of lighting, which allows you to control the switching on and off of your lights using wireless and on your phone as an app. Now, if you have those technologies, those are all related to networks, because they have some sort of a bridge or a router connector or a device interfacing the device, as well as the command that you are giving from your phone to be able to switch on, switch off, or essentially play. There could be a number of these. So you have smart speakers, you have smart lighting, you essentially have extenders, and they are also called what are called digital. They're all part of what is called digital technologies. They are digital equipment, and these equipments essentially allow you to facilitate communication between different devices. Then you have internet technologies. Now, internet technologies are technologies which enable the connectivity of internet and some of your online resources. So an example of this would be Internet of Things, IoT. There are devices like fridges, washing machines, microwaves, coffee machines. Now, these are all devices which can connect to a central device or a software, which is like a remote software, but they allow you to work and receive or send commands to them to be able to do so. And I'm quite lucky enough, to be honest. At home, I have a coffee machine which connects to the internet, and I have an app on my phone coffee maker app that allows me to select a type of coffee that I want to coffee machine to make, and I can send that, choose it on my phone, and it sends that instruction back to the machine. And as long as a cup is there underneath the coffee machine and milk is there, it will prepare that coffee for me. Now, these are devices which are basically called the Internet of Things, or devices which connect predominantly through the internet. And they are also one form or type of digital technologies. We've all heard of cloud computing. So devices nowadays, if I look at the server that you access for our learner management system, you don't have that server in the office. That server is in the cloud. The cloud allows us to do load balancing. It allows us to get connected at terabyte speeds. It allows us to essentially service all customers globally. And the maintenance of that server, which is although based somewhere in the cloud warehouse with a particular company, but they are managing it remotely, allows us to process data on demand, service our users, which are our students, for the purposes of, Moodling, or for example, accessing teaching and learning material. And these services and resources are predominantly all on the cloud, which means they are somewhere in the cloud. When I say they're somewhere in the air, not physically in the same place as we are, but they allow you to still access any sort of information, but through the internet and through one of your device, which could be a PC, a Mac, a laptop, or a tablet, or a phone. Then what we have and we hear about today a lot is about AI, or artificial intelligence. Now, artificial intelligence is again being run on computers. So OpenAI, for example, which has created ChatGPT, Claude, you have Perplexity, you have DeepSeek, which has been created by founders in China. They're all basically running on some hardware devices. So OpenAI is using NVIDIA GPU and CPUs essentially, but they are all essentially running what are called algorithms using some machine learning language to be able to simulate human intelligence. And that is what we get to see AI also being a part of what is called digital technology. I have a letter, I want to draft an email, and I want to draft it in a professional tone. What I can do is I can give a certain set of command to the GPT screen and say, could you draft this email for me? This is the reason I want to write this email, and it'll create that email for you because it has the algorithms and the repository in terms of resources available to be able to use that and then create the output to be able to provide to humans. So in such cases, artificial intelligence, when you look at, is using algorithms and machine learning language to perform tasks which can typically be done only by humans. But in this case, machines or equipments are emulating human intelligence, and that is why we call them artificial intelligence. So they are also a part of digital technology. Now, this is what all we are going to study in this particular unit. So the aim of this unit is to provide you an overview of range of digital technologies which are available across the board and are used in various different business sectors and environment. So as learners, we are required to investigate different areas, look at developing knowledge on some of these technologies and understand them to see how they can be put to use for a business purpose or for the purposes of usage in organizations and businesses. Now, there are, I think, five learning outcomes in this unit. So what we're going to do is every session that we do, we look at covering one learning outcome. So today we are going to be focused on covering learning outcome 1, which talks about understanding the evolution of computing and technology. And this has 4 assessment criteria in it that we are going to be looking at covering. There is no merit and distinction criteria in this particular learning outcome. Tomorrow's lecture, I think if we have one tomorrow, we'll be looking at learning outcome 3. Next lecture would be 2. The next will be 3. After that, 4. And then when we complete, we will be looking at learning outcome 5. Now, after the 5 learning outcomes have been discussed, we will get into what is called an assignment discussion session. And this assignment discussion session essentially is going to be looking at how do we look at doing the assignment for this particular unit. What are the questions? What are the tasks? We'll go into details of that in a session, another session that will be session 6. Now, as a tutor, I'm obviously been teaching this unit for the last 10, 12 years, but I just can't teach you anything. My aim is to cover all the indicative content which has been given by the awarding body in terms of the coverage of this lecture. So although I will bring in a lot more things from my side, because this is a field which is evolving, this is a field wherein there are lots of development happening, and I do a lot of reading myself. So I will try and share as much as possible in terms of latest news, trends, and technologies related to this particular unit, which will be relevant to the learning outcome and assessment criteria we'll be looking at. But in general, most of the presentations that we'll go through, the material that you study is going to be based on the coverage of the indicative content which the awarding body has given us as a bit of a guideline. So let's look at going into a bit more detail by going into the presentation and discuss this particular learning outcome in a great bit of detail. So let me just share my screen. Right. So what we are looking at is today learning outcome 1 in this, and learning outcome 1 primarily focuses on understanding the evolution of computing and technology. So this is going to be more focused on looking at how did computing or technology or computers as a technology came about, where do we see the beginnings of computing, and what all is covered in terms of the evolution of computing essentially that we talk about. Now, this is looking at a bit of a timeline, because at the end of the day, what we want to do is understand how did computing actually evolve. So when we do talk about the first generation of computers, we are talking about vacuum tubes and punch cards initially in the 60s and 70s, where we see the origins of computing actually happening. Now, the first generation of computers typically utilized, they did not have processors or the Pentium core processors or the Intel processors or the ARM processors, but they had what are called vacuum tubes and punch cards. So most of the instructions were essentially punched onto the punch cards and fed into the machine. And obviously some sort of processing was done by the machine to be able to produce an output. And these were the first generation that we look at. Now, the second generation consisted of high-speed programming. That means there was creation of languages like what we talk about, like COBOL, Pascal, initially in the early 70s and 80s. And these programming languages were used essentially to put or feed data into the computer for the purposes of processing. Now, at such point in time, these computers also then had what are called memory and memory chips. At that point in time, if I talk about the 70s, they were in kilobytes. They did not have the capacity to store data in megabytes or gigabytes. They were essentially kilobytes. So when we do talk about instructions in terms of how memory and computing came about, it started with vacuum tubes and punch cards. Then it went into what is called high-speed process programming and memory chips. In the third generation, we do get to see computers becoming big. They were called mainframes. They were as big as a room, but these computers were then capable of carrying out complex transactions because they had memory and chips within them, which allowed them to do complex transactions. The fourth generation is where we see desktop computer being created. We do see in the early 80s, desktop computer from IBM and Microsoft and Apple started to come in. They became the size which was manageable. There was some decent amount of processing power with a display unit, an input like a keyboard, and a mouse to control the movements. And essentially, most of this was disk operating system, or DOS as we call it. I don't know how many of you have heard about DOS. So at a later stage, Microsoft introduced Windows 3.1 or Windows essentially, and that became graphical user interface. So when we do talk about evolution of computers, there is something that I can bring across, to the slide, and that would give you a good enough idea in terms of how this development essentially started. So let me put it this way and put this across onto a slide. So now if you see in terms of how, computing and processing as a whole started, what you're going to be able to see is, if I can put this across, 1 second. So this is what you see right now in terms of, how the evolution of computers happened. We saw, one second. I'm not going to put it because I think it is putting it into a bit of animation. So we saw computers and the origins of it in the 1950s and 60s. They were called the Electronic Numerical Integrator and Computer, ENAC, as we call it. Then came the IBM mainframes in the 1970s. We had the introduction of the desktop-based computer in the 80s with the Microsoft operating system, DOS, coming in. Then we had the coming in of the World Wide Web or the Internet by Tim Berners-Lee in 1995. And then we have social computing and types of, explosion of computing happening because we look at the Moore's law, which is where the chips started to double processing power or the number of silicon transistors that we could fit into a memory chip or a silicon chip, started to work, and that's called the Murphy's Law. And that allowed every 18 months the processing power to be doubled. And this allowed the computers to become fast, more efficient. And what we do get to see today in terms of, modern computing, computers, something you have in your palm of your hand, like a smartphone, which is a very intelligent on a speed, form of computer. Another way, if I have to show you by bringing this across, would be to show you a scale of how actually computers started to, come about. So when we do talk about a scale in terms of nano meter, which is the process that we look at primarily in terms of how the chip capacity has helped the computers to become more efficient and fast. This is where you get to see that, okay, in the 60s, the computers were predominantly huge machines which consisted of vacuum tubes, and punch cards were used to put instructions into it for the process of purposes of processing. Then slowly and gradually we came to mini computer, workstations, personal computer, laptop. Today we have smartphones going forward, which allow you to do, multiple calculations and activities at one point in time or simultaneously. And then the chip size, which is the size of silicon, which is basically becoming nanometer, which is 5 nanometer process. So most of the Apple chips now are 5 nanometer. That means within one particular chip, there are 3 or 5 billion, between 3 to 5 billion transistors, which are able to multiply and magnify the process of calculations which the PCs can do. And because of this particular size and the technology allowing these many transistors to be fitted and onto a small, very small chip, it has increased the processing power or the number of calculations the PC can do in milliseconds. So most of the calculations today in computers can be what are called pentaflops. They are able to do calculations at the speed, which is probably not imaginable when we do talk about computers and the evolution of computers, way back in the 1950s. Now, there could be a lot of different forms of computers that you would get to see, simply because you might have to do a bit of research, but there are a few that I can bring across. This is probably what you see on your screen that I'm showing you is one form of computing machine that we can talk about. And give me 1 second, let me delete some part of it. Now, this is what is called Brixis. This was one of the machines which essentially allowed some sort of processing to happen. This was probably classed as the first computer called Brixis. And this computer was invented way back, in the 1950s, or maybe even earlier. I think I don't know about the exact timeline, but this particular machine, which we do talk about, came about in the early 50s, essentially, and this was the term which was called ENIAC, ENIAC. And this basically allowed some sort of calculations to happen, processing to happen, because in a way, this was, I would put it this way, the first electronic general purpose digital computer which was, invented. Now, this filled up a particular room. That means it was quite big in size. But as time passed and what we do see advancements happening in technology, at some stage, Alan Turing, in 1990s or in the early, I would say 1950s, he's called the father of modern computing, Alan Turing. That's a name that you need to remember. And he basically invented the field of computer science. And with this field then growing, developments happening, what we do get to see in the 1980s is the invention of the first modern computer, as we call it. And this is where we see the starting in of what we get to see at homes, like the desktop computer and things like that. So if I have to say that you need to read a particular article in terms of how PCs were invented or where the invention of computing actually started, there is lots and lots of information that you can go through. But there is one particular article site which I would suggest that you all need to look at for additional reading. And that will give you a very detailed tabular description of who invented computers, where the invention of computer science started, and how it all started to fall in place. This is the link that I would ask you to go to. Obviously, there are lots and lots of sites like Wikipedia and others which also provide good amount of information, but this particular site actually would provide information in a very structured manner, starting with the first computer, who made the computer, who invented computers, first electrical computer and components after World War II, role of Alan Turing, why is he called the father of modern computing, and basically coming up to the present age of looking at computer-aided, designing, which is CAD and CAM, and essentially looking at the first touchscreen or the touchscreen computer. So in terms of introduction, when we do talk about, early advances that typically happened in computing and where it all started, this is where I would suggest you need to look at doing a bit of reading, and that reading could be one or two different sites from which you understand the history and the evolution of where computing actually started from. Now, any questions on this so far? Any questions?
Here.
Okay. Now, there is a very good video on YouTube as well, which I would say that you need to watch. And I would suggest that if you watch that video, it has a very good timeline dating back to 200 BC. Now, you would be surprised when I say BC because when I do talk about the Egyptians, they had created a computer called abacus. I don't know how many of you have heard about abacus. ABACUS. Okay, abacus is a counting scale that they had created, which is more or less a bit which essentially allowed, calculator to be created. So I don't know whether, let me bring that image across in front of you, and I think you would be able to recognize this image. Now, this is also some form of computer simply because this was invented by Egyptians, and this was used to do very simple mathematical calculations. So using the Perl or the I would say hand operated calculating tool, or abaci as we call it, which is an ancient word and it means counting frame. So this was used in ancient times in China, in Europe, in Russia, and in the initial Hindu-Arabic, numeric system. And this essentially gave birth to the rise of what is called computing or some sort of modern calculator, because it allows you to do some, calculations by moving the sliding pearls across and allows you to remember what these calculations are. So if I go back into the history, sometimes people consider that, okay, modern computing started way back in 200 BC, which is where the abacus was invented. And this was the first known computer because it was what is called a mechanism to do counting, although being mechanical, but it allowed people to look at doing counting and keep track of this through the mechanical means. That means it allowed movement, to be done by the hands. And these computers essentially were, or devices essentially invented, were used for mathematical calculations. For example, how much toll is to be collected, or how much food has to be given in terms of weight and things like that. They were used as instruments to do those mathematical calculations. So there is a bit that you can do reading on, and this particular site would provide you this particular reading in about 2 or 3 pages. It's a 10-minute read, but it gives a very nice timeline, which unfortunately I can't bring it across onto a slide because it's too big the way it's been drawn. Although I can drag this picture onto a slide, but it is too big for you to be able to see. And if you see this particular timeline, this timeline shows a very interesting way of tracking how the history of computing actually started. So if I expand this, as you can see, it talks about first known computer of 200 BC. Then the word computer was coined as a title which was first ever used in 1613. Charles Babbage designed the machine, which is Brixis, which has started or allowed us to do some calculations. He went on to invent the Charles Babbage engine, and then slowly and gradually what you will see is the era of modern computing started from 1930s when Alan Turing invented this field of computer science, and a lot of development started happening in that field. So this timeline, essentially up until the introduction of the first desktop computer or the early IBM HP PCs and a Mac up until 1984, clearly shows you the history and evolution of how computing and technology has shaped has been shaped over the centuries and decade by different people. And that is what we need to cover in the understanding of, the first assessment criteria, which is explain the recent or the technological advances in computing. Is that okay? Any questions on this?
No.
So I'm going to put this as an image, on one of the slides, and this would be available to you, on the presentation when the updated is also uploaded after today's session. Right, let's go across to the second assessment criteria, which talks about, key stages of evolution of computing. So again, as I mentioned earlier in my discussion, that when we do talk about stages of evolution of computer, we look at 4 or 5 key developments. If you have to look at, summarizing down the history of decades and centuries into 5 or 6 main categories, we look at the pre-computing era. So this is where everything related to computing came about, or abacus from as early as 200 BC to the modern era, when we see the modern era of, I would say, computing starting with Alan Turing coining the term computer science in the late 1930s. First generation, as I mentioned, consisted of vacuum tubes, punch cards. They were large, expensive, and these computers were called ENIAC or UNIVAC. Second generation, mostly consisting of transistors. Third, of integrated circuit boards or ICs, and the introduction of memory, microprocessing, and silicon started happening in the 70s to 90s. And from 1990s, we are in the age of fifth generation, which includes growth of mobile, internet, computing, and also telecom spectrum like 5G, 3G, 4G, and 5G. And then now the oncoming of what is called the artificial intelligence. So these are key stages of computing that we need to capture. You need to be able to, explain each of the stage and give an example of what was the most important, or example of one of the types of devices which you can associate with that age, and that would be covered in what is called the evolution of computing. Now, in terms of major milestones, some of the things that I've grown up with in the 90s, if you look at the introduction of the internet. Now, the internet, which is the high HTTP kind of protocol, which was introduced by Tim Berners-Lee. But if you look at where did it come from? The internet was started off as what is called a sharing service, peer-to-peer sharing service by the US military department, which was called the ARPANET and DARPANET. So they were defense research, departments, and these departments essentially used some sort of a closed network to be able to share information, amongst different colleagues and in different locations. And this is where we see the origins of, what is called the, I would say, the origins of computing or internet actually starting. So when I say internet, what I mean is using some sort of a hypertext protocol technology, you're able to transmit information from one location to the other. This is what led to the creation of email by Sabir Bhatia in 1990s, which is where he introduced Hotmail, which was later acquired by Microsoft. And then slowly and gradually, this technology was then opened up for public use. And with the invention of hypertext protocol, HTTP as we call it, what we do get to see is that Internet Hypertext Transfer Protocol made that available to the mass public, wherein they were able to use an app. This was what was the HTTP protocol. This was an application layer which had the capability to encode information and transmit it over copper lines or any sort of system. And on the other side, this information could be decoded to get hold of the information. So with the introduction of the hypertext transfer protocol, which was nothing but an application layer, this protocol allowed transmitting of data to happen as electronic signals over any sort of a medium, and then encoding and decoding as a process happening at the sender's end and the receiver's end allowed it to retrieve that information back in the original form. So this particular protocol led to the creation of, or the introduction of this protocol and technology actually led to the creation of what is called the internet, and that allowed other devices, or I would say all devices which are computer devices, to be able to connect to each other using the internet. So why this invention was very important is because HTTP or hypertext transfer protocol allowed encoding and transporting of information to happen between two machines which were connected on a network. And this connection was established using the internet. And this connection then had the process through which, when the information was transmitted, it could be encoded. That means no information can go across to somebody else. If it was encoded, then it was transmitted. And once it was received at the other end, it could be decoded using this protocol into the original information, and using a device like a PC, be able to then see that information. And this allowed exchange of information to happen between clients and servers. And because of which, this technology, which is what was invented by Tim Berners-Lee, it then made it possible for information to be transmitted from one location to the other. So the coming in of the internet was very significant because it meant that information was no longer localized or restricted to a particular area, but it allowed information to travel or be transmitted from one location to the other. And that is why, what we do see in the later stages in the 90s and in early 2000s, the speed at which technology and this development in this field of computer science grew is because information could be shared instantly. You had dial-up modems, then slowly and gradually you had lease lines, and then the speed in the lease lines increased. Then came the fiber internet, and that allowed speeds of up to 1 terabyte to be applicable and accessible even in homes today or in commercial buildings and offices today. Now, it all started in the 1960s when the US Department essentially was able to use and create this public network called ARPANET. And this allowed communication and exchange of information to happen. And this technology was exploited in the 1990s to be able to produce what is called the hypertext protocol, an application layer which allowed this bit to go public, or that means it allowed people in public to be able to, or essentially general public to be able to access and develop this concept of internet connectivity, slowly and gradually leading to creation of operating system called DOS. Then later on, creation of graphical user interface system called Windows. And then slowly and gradually, as we see from early 2000s, the advent of mobile technology, the CDMA spectrum, the 2.5G, 3G, 3.5G, 4G, and today we have 5G telecom spectrum available, which allows speeds and connectivity to happen at 1 gigabit per second, as compared to when we talk about dial-up modems. And the speed of internet using dial-up modems used to be 128 kilobytes per second, or 256 kilobytes per second, or 512 kilobytes per second. So we have come a long way from where the speed was in kilobytes to where the speeds now is in terabytes as far as connectivity is concerned. So this is what you need to look at in terms of the range of information and communication technologies which are currently available as far as this field is concerned. So there are lots of different milestones that we can cover, but generally there are these 5 eras, as we call them, in which the major developments in computing and technologies happened. And what did they lead to? They led to the creation of internet, led to the creation of DOS, or graphical user interface based operating systems, led to the creation of PCs and devices today that we use, which are mobile devices. And in the current context, that has led to the creation of what is called artificial intelligence. Now, these devices are used across different sectors: education, healthcare, business, communication. And I've given a few examples of how these developments in the technology has made an impact into each of these sectors. So when we talk about communication, you had the SNS, or social networking service, which came about in the early 2000s with Facebook, LinkedIn, coming out. But today, without these services, it's very difficult to look at understanding that if we don't have them, would we survive? It'll be very difficult to get hold of information if we don't have these services today. So the amount of development which has happened in this field, which has led to better communication, increased communication, faster and quicker communication, or instant communication, has happened predominantly because of the developments in technology which have happened on the internet side or on the computing side. Any questions on this?
No, it's clear. Everything is clear.
Now, some of the emerging, parts of it that we need to look at, just as a brief overview. There are lots of developments happening in this field. Emerging technologies which are coming. Quantum computing is one of them. It is the ability wherein you are able to put computers in grids, and this allows computers processing power to be combined, which allows that increased processing power to be able to do complex transactions or complex calculations. And that is what we get to see in quantum computing, which is coming forth now as a very advanced area of computing going forward. We have Internet of Things, blockchain, 5G, and obviously, some of the bits are also being integrated into what is called sustainability, because we are producing so much equipment. One part of the thinking process is also to look at developing sustainability in this, that our devices can be used for longer duration, can last us longer, do not need to be replaced. And in such cases, we are thinking about the environment, we're thinking about the climate and other things, because when you have, say, a data warehouse in which you have maybe tens of thousands of servers connected, they're using an enormous amount of electricity. They are using air conditioning essentially, because you have to keep the machines at an ideal temperature to be able to run them 24 hours. So in such cases, sustainability in computing is also being talked about going forward. Now, some of these are discussed in a bit more detail in some of the slides that I've created for individual criteria. So when we do talk about technological advantages, we are in 2025. So some of the things that we want to look at in this part, if I show you a full screen, you'll be looking at things like quantum computing, which started in 2019, artificial intelligence, and the advances in machine learning language started in 2015. But we do see with the coming in out of ChatGPT or related such software, they were introduced in 2022 and also in 2023. But now we are getting into things like 5G technology, which also came out in the early 2019. But if we do talk about 2025 and above, we are looking at the developments predominantly in edge computing, quantum computing, and artificial intelligence. So a couple of slides that I've created essentially that you can go through. to look at reading it in a bit more detail have been done related to this particular part of evolution of computing and technology. Is that okay?
Yeah.
Now, the second assessment criteria very quickly we'll look at would be to talk about, range of jobs related in this sector. What kind of jobs are there in this sector? So if I was doing a computer course, what I want to understand is what are the types of jobs available to me as a person who's actually completing this course. Now, there are 94 different types of roles within IT that you can get into. So when I talk about roles, I can talk about things like network engineer, data scientist. I can talk about an IT administrator, a software engineer. So when we talk about classifying individual types of roles and specialization that you can have in terms of your job role within computing, to the best of my knowledge, there are 94 such roles that we can actually look at in terms of job profiles within the IT sector. Now, these are some of them which are important and some of the high-paying jobs or profiles which people would like to get into have been listed out in this particular table. So you have data analyst, data scientist, ICT project manager, you have Scrum Master, you have a software developer, you have programmer, you have front-end developer, you have cybersecurity analyst, you have testers, you have network engineers, cloud engineers, infrastructure engineers, system engineers, you have support technicians, people who are looking at programming and doing things in AI, machine learning language, and then obviously people who have lots of years of experience, have good broad understanding on a good number of technologies, and also work in consulting role within IT. Now, these are some of the professions which I've listed because the assessment criteria talks about the types of roles that can be present or you can do in terms of ICT, the information communication and technological, pathway. So if I was to study computing and if I was studying computer science, what kind of jobs or job profiles I can get into? These are the kind of job and job profiles I can get into, from a career perspective. And that is what we are required to look at in, the assessment criteria 1.2. Now, these jobs are available across public sectors, private sector, banking and finance, retail and logistics, obviously within education and research. And each of these roles have specific requirements. Now, if I were to talk about that I want to be an IT engineer, then I would need to go into a bit more detail in terms of what kind of an IT engineer. Am I going to be in support? Am I going to be looking at doing troubleshooting? Whether I'm going to be looking at network support or in general cloud support or any sort of a remote software application support. So within a IT technician role, I can have 5 different types of roles. And these are all specific opportunities which could be present within each of the sectors that you decide to work in. So if I decide to work in railway, for example, or rail, network rail, then, although the main part of the function of the organization is to transport passengers from one location to the other because they own a rail network. But as a computer engineer or as a software IT person in network rail, I'll be responsible for drawing up, say, maps, routes, looking at optimization in terms of IT infrastructure, maintaining networks, or in some cases ensuring, connectivity between different, say, for example, stations or cities. And that would all be related to the role of a software engineer or a computer engineer working within network rail. Now, any questions on this so far?
Actually, I'm interested in the jobs related to that relates IT with the business administration. So what do you think can be
So
like?
when you look at jobs in IT administration, essentially, we are going to be talking about jobs which are related to, for example, specifically when you talk about IT administration, you'll be looking at either a hardware side of things or software side of things, because IT administration could be a broader role. But when we do talk about IT information technology or IT administration, what you're looking at essentially is roles which could be further divided into what is called computer administration jobs. And these could be in hardware, software, or any sort of I would say any sort of departmental role which could be looking into automation of things. So when we do talk about administration side of things, it could be that you're working as an IT administrator in the office, wherein you're responsible for an office network.
Business administration.
Yeah,
I'm sorry to interrupt.
sorry.
I meant administration, like how IT interacts with business administration.
So
What do you think jobs,
okay,
related
so
jobs are open?
when you look at business administration, or when you look at a small setup, for example, if you visualize, and look at a business or a small organization, you would generally see that the small, what all the first thing I would do is identify what kind of equipment or IT related equipment does the organization have. So I will go about making a list of that equipment. That if I'm thinking right now, I'll start off with things like, if we have a premises, within the premises, you could have CCTV, you could have a photocopier, some PCs, you could have software installed on PCs. You could have some gadgets or devices like laptops. You could have a telephone system. You could have a touch screen to look at incoming and outgoing of guests. You might have some sort of a fingerprint system or a biometric system to look at taking down staff attendance. You might have IT equipment like routers or switches, phone systems which could be connected through VoIP and internet. And these would be the kind of things that you would have running in an office or in some sort of a small business. Now, coming to the question, how does IT interact with business administration? Now, in such an office which has a couple of employees working with so many of these systems or IT equipment available, there would be somebody in the organization which would be an IT administrator or a administrator looking after the IT equipment part of it for the company. And that could be looking at basic functioning of the IT system, like phone system, looking at, say, for example, apart from the phone system, the telephone system, or in some cases, looking at individual PCs which employees are using within the organization. So there is a bit of an interaction which is going to happen between the person in business administration and with the person who is specifically tasked with looking after these systems to make sure they're up and running, they're working, there is nothing faulty, and employees, time is not, taken off or wasted because the PC, say, for example, is not working or any sort of equipment or phone line is down or things like that. So when we do talk about the interaction between business administration and a person looking after IT, both of them are going to be working quite closely because their role would be to try and ensure that anything in the organization which is being utilized for the purposes of drawing business, generating business, dealing with customers is actually working, is essentially functional. So if anything is to go down, you would probably, as a business administration person, if you're in sales, reception, admin, operation, you would straight away call the IT to say, okay, my PC is hanging, or my PC has got a virus, or my PC is not connected to the internet. And the business administration person would get then support or help from the IT administrator, who's essentially equipped and expert with solving this problem. That means how and why does the machine not connect to the internet or connect to the server network? He might come in and do a bit of troubleshoot, and that would get you functional again.
Yeah, it helps the business to be more efficient and effective.
Correct.
Yeah.
Now, the third assessment criteria talks about transferable skills learned from personal computing. Now, there are lots of different skills which people can pick up while using computers. One such example which is given is that a lot of kids today do a lot of gaming on Xbox and PC. Now, this is a skill which could be utilizable or useful for them in the future. Can you think of reasons why this will be useful for the kids in the future?
For the
If they
kids,
do a lot of gaming?
maybe make them faster or like think in a different way.
Sure. So when you look at, say, for example, if we look at one of the applications of what computers can be used for, and how do we look at transferable skill is one such application we can look at is, say, for example, gaming. Now, a lot of kids today, even adults, engage in gaming. Now, when we do engage in gaming, what is happening is we are getting used to the PC and PC-related environment. One of the things that could be a transferable skill would be that because I'm using it for gaming and I'm using joystick or keyboard or things like that to be able to work on the PC, one of the offsets of that could be my typing speed could increase. I could get more familiar with the keyboard. I could start typing without having to look at the keyboard. And these could be transferable skills that you could develop by developing a sharp state of mind to be able to react, or maybe certain applications which you might be able to run, which you would have not exploited or looked at in the normal course of things when you are actually looking at using the PC. So some of the things that you would get to understand by using gaming would be that it will help you in developing higher level competency skills on the use of PC. And that one simple example could be, the example of being able to type quickly, because when you're looking at gaming, your reflexes and your reactions to the key presses and other bits on the PC tend to be higher. And that could be skills that could be transferred over to your general purpose usage of computing at a later stage in the office or in a different environment. So when we do talk about transferable skills that people can acquire because of computing, we are looking at things like problem solving, critical thinking, hand and eye coordination. Sometimes I'm typing on the keyboard now and I don't even need to look at the keyboard because my fingers and my brain remembers what keys I need to press. And my typing is very accurate, even if I don't look at typing by looking at the keyboard. So things like fine motor skills, attention to detail, team collaboration, communication skills, a bit of time management, and adaptability are all skills that you're developing because of the use of PC in some shape or form. And these skills then can be applied in real world applications when you're faced with these real world applications outside. So one of the things that you could look at is your people who have high typing speed can also be seen to have what is called quick reflexes. So this tends to come from the fact that if they have, let's say, a quick reaction time when they are using the PC, they would also in general have a quick reaction time when they are faced with a different situation. So in such cases, some of these skills can be seen as transferable. You gain advantage by doing something, and that is something that you can transfer over to another area, and that would be beneficial for you from a point of view of carrying out that activity. Is that okay?
Because you're learning something about like learning a language of the computer,
Correct.
which would make you smarter and sharper.
Correct. So we need to think of such areas. Gaming is one such area which I've shared, but there are a number of other areas that you can think of in terms of how computing or use of computers can be seen as helpful in terms of gaining new skills, and at some stage, transferring these new skills to be able to use in real world, real life situations. Now, one such example we also get to see sometimes is because your reflexes generally get faster when you're playing games, you are able to treat those and use them more so when you're driving. So sometimes to a certain age and within a certain age groups, you are able to see those reflexes acting faster, far more quicker than probably people at an older age. And that is because they're still able to use computers and they're able to acquire certain characteristics which they can see can be transferred over to other areas in terms of their working or better working. Now, last assessment criteria that we have is interpret a problem and find an appropriate digital solution. So here, what we have to look at is what is a problem that you face. You have to think of a real world problem and then look at what kind of solution you can get from, using digital technologies or computing. So here, think of a real world problem that you have in any aspect or any area of your working in the course or otherwise. Can you think of a real world problem that you face which you can think can be resolved through the field of computing?
Maybe like connecting with people that are far away from you.
So when you say, sorry, come again, netting or chatting with people?
Yeah,
which are living far away from you.
yeah.
Okay. So
Or like
anybody else,
Zoom.
any other
Yeah,
ideas?
yeah.
Clementine, Promise, any other
Like
idea?
learning, understanding more about what, like getting more information
Yes.
that you need. Yeah,
So if I give you, if you look at the common activities that we carry out on a day-to-day basis, right? One such problem that we sometimes face is, even we face that in the office, is the internet goes down.
yeah,
For a couple of seconds, the internet connectivity breaks. Now that could pose a problem. The problem is the email, if you've pressed send on it, the email does not go out, it stays in the outbox. If I have a bit
yeah,
of a connectivity issue right now, my session with you guys would have a bit of a breakage in the middle, and that would mean that I might have to start the recording again, or I might have to look at, some part of the session being repeated because there was a lag in between what I said and what you could get because there was a disconnect in the recording. So in such cases, this could be seen as a problem. What is the problem? Disconnection. Problem, breakage of signal. Or for example, if the network goes down, then this is a problem which would need to be addressed before you could have a solution, or you could actually, let's put it this way, find a solution for it. Now, if this breakage happens quite frequently, but it only happens when it is raining outside, then we can understand that during, unpleasant weather, sometimes wireless internet or connectivity can be affected because it interferes with the weather pattern or the way the weather is outside. It makes it difficult for the signals to be transmitted. Would you agree?
sorry.
Assuming that we are facing a bit of um,
Weather
disconnection within
conditions.
the internet and it's raining outside. So this could be a problem because when it rains, the connectivity is not good. It deteriorates because of lightning or other such factors when you are connecting through the internet through wireless. So in such cases, this could be a problem. What could be the problem? The problem is variation in speed of internet. It could be problem could be connectivity. Problem could be frequent disconnection of the connection between you and somebody else. If I'm doing this lecture right now, and if it is raining outside and the connection breaks, I have to restart and I have to reconnect, then this is a problem, right? What is the reason of the
Yeah,
problem? The reason of the problem is rain, or because in this case, weather is not good outside and that is affecting wireless connectivity, right? How do we find a solution? So in some cases, we have a backup connection in the office, which is a dial-up or a lower connection, which still allows the telephone calls, the internet, and the network to continue if the main network or the lease line is to go down, right? So we have an appropriate solution for that problem, that as a backup, say, for example, a real example is that at university, we have 200 Mbps, lease line, which is a dedicated line to our office for internet connectivity. But assuming if the weather is bad or the lease line breaks down, we have a backup 10 Mbps line, which allows us to still run our telephone systems, our systems in general, and do Zoom meetings and things like that. And that is where the solution to the problem lies. So you have the main connection and you also have a backup connection which keeps running just in case if the main line is to break down or the main connectivity is to go down. We have a backup connectivity which still allows us to connect and run some of our basic systems in the office. Is that okay?
yeah,
So
yeah. Clear.
this particular task talks about what we have to identify, what is the problem. And then when we look at the problem, we need to look at what digital technology or equipment allows us to solve that problem. Okay.
Yeah,
So I have taken a couple of examples in terms of there could be manual data entry delays, which is because of internet. There could be slow customer response time online. If your website slows down, for example, because of connectivity or because of overload, that means there are too many people trying to log into your website. This is something that we see when Apple introduces a new software upgrade. It basically ensures that the software upgrade, is the load on the servers and the software is downloadable from different regions in the world so that it does not crash its website. And that is a digital solution that they look at by ensuring that the cached version of the software is uploaded on different parts of the in different servers across the parts of the world so that load balancing can happen and it does not bring the site down or the server down. So there are a number of such examples that I've given here, which are seen as problems, and how do we solve them using digital technology is what I've given in the form of a table. Is that okay?
Yes. Yeah.
So these are one or two such examples that you need to think about to be able to cover this last part of the assessment criteria. Now, towards the end, what I've done is I have given you a few articles to read. And these are because I want you to do a bit of reading to cover this part of the, learning outcome. So who invented computers is one of the articles that I would say you need to go ahead and read simply on this particular website, because this will allow you to get a bit of a background in terms of, the invention and evolution of computers.
Yeah.
Okay.
Yeah.
Good stuff. So that brings us to the end of today's discussion on Learning Outcome 1. If there are any questions, please ask me.
No, everything is clear until now.
Okay.
Sometimes I keep sending emails because when I study it, it's different. I see it from a different perspective, you know? That's why I keep asking. I have too many questions.
No, that's absolutely fine. I think there are two such articles which I want to show you, which you can look at for additional reading. One is on the BBC Bite Size. It says Technology Through Time. This is a good article to read through, which will be useful for the purposes of, I would say, understanding how things have evolved in the field of technology. There's another good article or a website which basically has the evolution of computing. And this is also something which I would suggest that you go ahead and read. These articles are about 10-minute reading, which I would suggest that you need to look at from a point of view of, understanding Learning Outcome 1 in a lot of detail.
Yeah.
Okay. So very quickly and briefly to show you some of these that I've got opened up. This is the link to one of the article sites, Evolution of Computing. It talks about the history of computing, has a lot of good graphical images to show how computers were created. This particular image, which I brought across, was from this particular website. As you can see, levels of computing, how advances have happened. So it's a good read. There's a second one, which is the BBC Bite Size. This talks about how technology has evolved over a period of time. There's a very good video of about 5 minutes, 27 seconds that can be watched. And this is something, which will allow you to go into by looking into other jobs in the IT sector. BBC Click is one such program that I watch personally. And I would suggest if those of you, who are doing this qualification, I would say you should go into the BBC technology page of the website and subscribe to it and make it a point to watch the BBC Click, site episodes when they are broadcasted on BBC iPlayer. And the last but not the least, Who Invented Computers, is another article, which is a very good one because it, in a very brief and detailed format, provides you the whole history of how the timeline of computing came about and where are we with regards to today, with regards to the inventions and how modern computing is actually shaping up.
Yeah.
Okay.
Okay. Thank you, Mr. Rahman, very much.
Good stuff. So I will see you in the next session. Let me just have a quick look. So our next session is on, one second. What is the next session? So tomorrow is our next session, right?
Yeah.
Tomorrow we have the session at 10 a.m. and 9 a.m. in the morning.
9 a.m. Okay.
Yeah, tomorrow is the next session. So we'll be looking at covering Learning Outcome 2 tomorrow.
Okay.
And then we have the
Thank you,
next
Mr.
session on Monday. Sunday, there is no session. Saturday, Sunday, there is no session. Then we have one on the 21st. And then after the graduation, which is on the 25th and 26th.
Yeah.
Okay. I'll drop the message onto the, on the WhatsApp group so that you are familiar with what the next session is and when that next session is, and you're able to join. But just for tomorrow's session is at 9 a.m. in the morning, and I will see you and we will discuss learning outcome 2.
Okay. Thank you, Mr. Rahman, very much.
Thank you. Promise any question at your
Very
end?
much appreciated.
No, thank you.
Okay.
All these files, I can find them on Moodle, eh?
Yes, this PowerPoint, if I quickly show you right now, is actually all available on Moodle, and you should be able to download the latest copy of the presentation along with, what do you call the video, which I will post across in a couple of seconds to you after the session. So let me just quickly show this to you as well. Just 1 second. Here we go. And let me share my screen. So when you log into Moodle, you're logged into Moodle, all you will do is primarily go into, the ATHE. Number 3rd from the top is the Diploma in Information Technology. When you click on this, you'd see the whole course. The best thing would be to click on collapse all first. And then when you have collapsed it all, what you would be able to do is essentially click on this unit, which is Introduction to Digital Technologies that we are discussing today. And this unit is going to be having all the details that we are discussing, which I'll show you now. So when you click on this left arrow here, it'll open the unit up. That is the unit specification that I showed you initially. When we started the unit, there is obviously the assignment brief, which we are going to discuss after all the sessions are complete. And then there is a book which is recommended for, digital technologies in digital computing. So there's a book that I've got, which is available here. And then all the presentations that we are discussing. So I've just uploaded the latest version of the presentation that I've updated today, which is LO1. Then you have LO2, which we are going to discuss tomorrow. And all the learning outcome presentations are then, available here in a sequence.
Okay.
Okay. And then any articles that I upload to the presentation or any videos that I upload to the presentation, you're going to essentially find it here. There are some videos that I've also created, which are, pre-recorded lectures, and I'll be uploading those videos. I'll show you one for the learning outcome 1, which has been done. This is a 10-minute shortcut presentation video of the learning outcome 1 presentation. And if you watch this video, essentially, it will give you an overview or a synopsis of what we have covered today as far as, this particular session is concerned in detail.
Okay.
Okay?
Yeah.
Good stuff. So I will see you guys tomorrow at 9 a.m. And till then, take care and bye for now.